Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we talk about, everything from basic electrical theory to different types of equipment we install. We take a look at how some of that equipment operates and so forth. And then, of course, we always like to look at the codes and standards that apply to us as we install and, of course, have to maintain that equipment out in the field then. So anyway, I'm Randy Barnett. I'm your host for today. This EC&M Tech Talk is brought to you by, of course, EC&M Magazine. If you haven't already, you go to ecmweb.com, and in that upper left-hand corner, there's a menu. Click on that drop-down menu, and the very first item that you come across is premium content. Make sure you sign up for the premium content if you haven't already, because it entitles you to tons of free information, all right? Free to sign up, lots of free information about all the different electrical topics that we face out there in the field. Let's get started. Today we're going to talk about NFPA 70B. And you say, I know that's the recommended practice for electrical equipment maintenance. Well, it used to be, but not anymore. Big news, right? If you haven't heard already, it's changed. It's no longer a recommended practice. It's now an ANSI approved standard. It went into effect in January of 2023. So it's in effect right now as you listen to this. Now, the thing about it, it is ANSI approved. It is a standard. It went from recommended practice to standard. So that means the terminology went from you should do this to you shall do that. So as I say, now NFPA 70B is a must-do item for us. We've got to get our electrical maintenance programs together out there in our plants and facilities and so forth. And lots of opportunities, right? If I'm a contractor, I'm thinking about, well, what kind of opportunities does all of this required maintenance present for me now? Or if I'm a technician, electrician, a worker out there, I'm thinking, oh boy, what else do I get to do? What other types of jobs and opportunities are for me out there as I learn more and more about electrical equipment maintenance? Now, the way it works is, I'm going to take just a simple ruler here. All kinds of things you can do with these rulers, that we have today. And I'm going to go ahead and make myself a triangle. Okay, so now I've got a triangle. Oh, get it all straight. There we go. I have a triangle. And so I could say, well, this side of my triangle represents the National Electrical Code. This side represents the NFPA 70E standard. The bottom of the triangle references the NFPA 70B standard for electrical equipment maintenance. We know we use the NEC to go out and build our buildings so that they're safe, aren't they? We install our electrical equipment so that buildings don't burn down and people don't get electrocuted. We have to go out and work on that equipment. And when we do, we want to follow the requirements of NFPA 70E and make sure that we use our safe work practices. And we also know that electrical equipment will fail if we don't maintain it. So now we maintain it according to a new standard, NFPA 70B. So if we install it properly, we work on it properly, we maintain it properly, right here we've got our safe work environment, don't we? Now, if we never installed the electrical equipment safely, if we didn't follow ampacity requirements and things like that, what would happen over here to our NEC side? We would lose our NEC side, and our triangle, our safe work environment would just collapse, wouldn't it? And the same is true. If we didn't work on equipment safely, if we didn't maintain it, we know it wouldn't work properly. Now, we know we have to maintain electrical equipment. If we don't, we know it's going to fail. Just like anything else, like your car, right? Vehicle, truck, whatever you've got. If you don't change the oil in that vehicle, eventually it's going to be bad news, isn't it? I mean, you can get down to that 10% of engine life left or whatever, and then you still don't change it, and you hit 0%, the engine doesn't blow up, does it? But if you keep driving that vehicle and never, ever, ever change the oil, one day you've got to buy yourself a new engine, don't you? Don't want to have to do that. Same is true with our electrical equipment. If I never maintain a switchgear breaker, we know it's going to fail. We've got statistical data on that. And we know about how long it's going to take and all those type things. So we have to do maintenance on our equipment. So the new NFPA 70B is in effect. It's ANSI approved, and it requires we do electrical maintenance. The format is a little bit different if you're familiar, if you're used to using the National Electrical Code. In the National Electrical Code, we find chapters and articles. In the NFPA 70B, it's a little bit different format. And so, for instance, if we were to go to Chapter 15, we would find section, probably 15.1, 15.1.1, 15.1.2, 15.1.2.1, and all of that. So that's how it's laid out. Also significant in the NFPA 70B, there's no informational notes like we have in our code books. But I think it's a good thing. Here's why. Because there are many of the sections that have a little asterisk right by the section number. That tells you to go back to Informative Annex A. And if you go back to Informative Annex A, it is a collection of a huge amount, of informative annexes then, is what I would call them. It's all kinds of, or informational notes, in other words. So it's lots and lots and lots of explanatory information back in Informative Annex A for us. So that's a good deal. I think that's really important. Now, so if we look back, what all does this standard cover? It covers certainly our electrical and electronic equipment and the systems as well. It also covers communication systems and equipment. The purpose, no surprise, NFPA 70B is out there for practical safeguarding of persons, property, and processes, because they can cost us a lot of money if we start making bad products, if processes are damaged and so forth. The financial loss can be huge for a company. So anyway, we have to protect people, property, and processes from what? From the breakdown and malfunctions of electrical equipment. That's what it's all about. We don't maintain it, it won't be safe, it won't be reliable, and it's going to cause us lots of problems then. What types of facilities are we talking about? 70B says, well, some examples are industrial plants, institutional and commercial buildings, large multifamily residential complexes. Doesn't apply to our homes, our individual single-family dwelling units and so forth. So the big difference then, and we can go to Chapter 3, which is definitions in 70B, and it defines the standard for us. And it talks about the difference between should and shall and all that. It tells us it's a mandatory requirement then. We also find lots of other good definitions from commissioning of systems and equipment. Some of the important ones, I think, is talks about different types of tests that we have. So we're probably familiar with acceptance testing, where you buy a new piece of equipment before you sign on a dotted line that, yep, I accept this piece of equipment, we'll pay for it. You want to make sure it works properly, does what it's supposed to do, functions properly and safely and so forth. That becomes excellent data for you, all of those tests you run now, to go into your electrical maintenance program, your EMP as they refer to it in 70B. Other tests that you're probably familiar with, we have our as found test and our as left test that we do on electrical equipment. So if I'm going to go out and do something like, an insulation resistance test on a motor, I want to know what's the insulation resistance when I first get there and check it. And I want to record that data, certainly. And then what about if after I'm done, maybe I had to dry the motor out or something like that. What's my as left data looks like? Then we have something called standard test and enhanced test in 70B, which you may not be familiar with. Standard test, this is what you can guess. It's the standard test that we do at our regular intervals, our routine maintenance, insulation resistance testing, visual inspections, mechanical inspections, cleaning of equipment, and so forth. But then what if we run into a problem? For some reason, we think we might be having an issue, or maybe it's a really critical piece of equipment. We don't just want to settle for those standard tests. We want to do some more enhanced testing as well. Let's take some examples of that. Now, I can do something like, if I'm going to do a standard test on, I don't know, let's take something like this, insulation resistance tester. So now I've got an insulation resistance tester and got a couple of leads I could plug into it here. And so I have a motor. I've de-energized the motor. I've verified it's an electrically safe work condition. I can clip this black test lead onto the frame of the motor or some good grounding connection on the motor. And now I can take the red test lead and touch it to the terminals, the de-energized terminals right on the motor. and I can measure the resistance of those windings. And they have to be within a certain value. But let's say this is a really critical motor. Maybe it's I don't know, maybe it's a chill water pump in my data center or in a hospital, someplace like that. Or maybe I think that motor might be getting close to failure. I just want to do some more verifications on it. Or maybe all of a sudden my as found test really dropped off from the last time that I checked the insulation resistance on that motor. So what I can do is I can go to some enhanced testing. I can take this same insulation resistance tester, and on that de-energized motor, I can do something like a dielectric absorption ratio test, a polarization index test, and find out, uh-oh, my motor does apparently have some moisture in it. I can dry it out, go back, redo my test, record my as left data, and find out that I have helped save my motor, Or let's say that motor is being supplied off of a drive. Though, by the way, those were examples of de-energized tests, weren't they? I used a standard and enhanced testing, de-energized when the motor was de-energized, electrically safe. Let's say that the motor is running now and I'm damaging the insulation on that motor. I just replaced that motor 2 years ago and it's failing again. It should last a lot longer than that. That motor's being supplied from a variable speed drive. So in that case, what I might want to do is take another type of piece of test equipment, and now with my motor online energized, I'm going to do some enhanced testing. Now I can do some power quality checks on my motor. Find out that, oh, maybe I need to put some types of filters on my variable speed drive, or get a different type of motor with different types of winding that's rated for that drive, so that I don't destroy the insulation as I get spikes and different power quality issues out of that drive for that motor then. So, you know, examples of different types of testing that I can do, all talked about in NFPA 70B then. And if I do that, don't you think I'm probably going to improve the reliability of that piece of equipment, make it safer for the long term, cut down on my downtime? And it just makes sense to do electrical equipment maintenance then, doesn't it? Now, not all on all equipment maybe. As I say, we have some equipment that's more critical than others. Chapter 4 says, hey, tell me about this equipment maintenance program, electrical equipment maintenance program. Who has to set it up? What has to be in it? And so forth. Well, we have to designate an electrical maintenance program coordinator. It tells us in 70B. Somebody to run the program, right? Go out and make sure that we set up the program properly, have procedures developed, workers are qualified, and all of that. The things that we have to do as part of that program, we have to go out, and that coordinator is responsible to go out and get inspections done on that equipment. What's its current conditions of maintenance right now? You're familiar with that term if you've had training on and follow NFPA 70. It has to cover the principles of our electrical maintenance program, the controls, how we're going to control and maintain the program itself. We have to do incident investigations, and how are we going to do that on a piece of equipment we're talking about? So now all of a sudden I go down there and one day the smoke is just pouring out of that motor. I've got to do an investigation on that. Find out what went wrong. I mean, potential danger there. It could be a loss of revenue. It could have caused a fire in my facility, or it could have injured somebody, or all three of those things. So we need to investigate it and find out what went wrong with our electrical maintenance program. Did we not do the proper type of testing on that motor? Were our intervals between our tests too long? Were our predictive maintenance data, was there something wrong with that? So lots of things that we can look at, find out what's wrong, and then we can correct the problem, can't we? We want to make sure it doesn't happen again. And finally, we're also required to go out and audit our electrical maintenance program periodically, as well as we're going to do field observations on the people out there doing electrical equipment maintenance to make sure that they are not only qualified persons in accordance with NFPA 70E, you know, they've demonstrated skills and knowledge on the construction operation of their equipment, they recognize the hazards and know how to avoid them. But they also know how to operate that test equipment and run that, run that particular electrical maintenance test. So those are the things that we must include in that electrical maintenance program. The coordinator then has to determine the scope of work, determine the plan You know what type of schedule, predictive maintenance, interval scheduling, whatever we're going to do to set up our preventive maintenance program, and what particular equipment is critical to us. What equipment is important to go out and do the maintenance on then, right? And then that coordinator is also responsible to make sure that he has qualified people for his electrical maintenance program. And we have to be qualified, remember, not only as for safe work practices, but also we have to be qualified on that particular equipment and the system, whatever it is in, as well as that particular test equipment and how to use it. Got to have written procedures for this. It's the only way we can keep track of all of this and make sure that all of the tests are done properly. If one person does that spot reading test for 1 minute and the next person comes along 6 months later to test that motor and doesn't know that you're supposed to let it run for 1 minute, we've got screwed up data. All of a sudden our electrical maintenance program starts to fall apart. So we've really got to have written procedures if we're going to have an effective electrical maintenance program. As far as training, we've got to pay attention to qualified persons. We've talked about what they have to be trained in and qualified in. You've got to follow all of your safety requirements when you're out there doing your electrical equipment maintenance. If I'm doing a high pot test, I may be raising the voltage on that 4160 switchgear or something to significantly high voltage levels. I better keep all unqualified people away. I better establish that limited approach boundary, set up some barricades, make sure that nobody gets a shock. Generally, most of these tests, at least as far as for the de-energized testing, whether it's a 1 or a 2 test, arc flash is not an issue. It's going to be shock that's going to be the problem for us. So the employer is required to go out and annually inspect and make sure that all of these tests are being done properly. Now, to set up your program, get your survey and analysis done on your electrical equipment. Come up with some planned inspections, start writing your procedures. Make sure that you consider new equipment that you're getting installed, rework of existing equipment, retrofit work, those type things going on as well. Include that all as part of your analysis in your electrical equipment maintenance program. Make sure that you include cleaning and visual inspections as part of your procedures. Follow your equipment manufacturer's recommendations. If you need more guidance or if the equipment manufacturer recommendations aren't available to you on some of your equipment, go to NFPA 70B and find out more details then. Also, you have to make sure as part of this electrical maintenance program that your diagrams are all up to date. Your single line diagrams, short circuits, coordination studies, arc flash studies. Hey, I may want to know that. I'm your electrical maintenance guy going out there to do some work in your plant. I have to open up this panel board, unfortunately, and do some work on it while it's energized. We've got to pull this cover off for whatever reason. I fill out my energized work permit and all that. I want to know about the arc flash study. I'm concerned about that upstream feeder breaker. Has it been maintained properly? Because that's what's going to determine the size of the arc flash. Nothing in here, right? So I want to know about that arc flash study. Did a transformer get changed out somewhere and we didn't include that in our 5-year review on our arc flash analysis? So all of those types of things, all of those types of one-line diagrams and studies and so forth, we need those up to date. They need to be part of the electrical maintenance program. The electrical maintenance people must know how to read and interpret that data and come up with their own determinations and interpretations when they get out there in the field to do some work. We just don't rely on the label and say, well, that's what the label said, boss. No, we ought to be smarter than that, I think, right? As far as the fundamental tests then that are identified in NFPA 70B, takes a look at a few things. And this applies to all the types of equipment that we're going to go out there and work on. We have to look at things like bolted bus connections, conductor terminations inside of control panels and so forth, conductor connections, and especially things you think like on a disconnecting means, like a 3-phase disconnect, safety switch or whatever. We don't want those overheating. So one of the best things we can do, 70B tells us, is an infrared survey on that equipment. And so we need to follow and go through our procedures, for infrared surveys. And we're looking at what? The delta T, the difference in temperature between 2 points, and make sure that one is not significantly higher than the other. We could use thermal sensor 70B inside of equipment to check for overheating conditions. We can do contact resistance tests on terminations and bus bars and so forth. And for that, it's going to be really low values. So we're going to have to use a micro-ohm meter in order to measure those values. We can always retorque connections, verify the torque, right? And make sure that it's a proper torque. So those are different ways that 70B says that we can check our connections. We can do our installation resistance like we just went through on our motor. If the equipment's rated over 1,000 volts, we have to do some of this high potential testing we talked about. And there are different types, partial discharge testing, ultrasonic testing we consider, and so forth. So anyway, different types of tests, once again, energized or de-energized, standard or enhanced, depending on the criticality of the equipment, the conditions of the equipment, and once again, whether we're using the interval method, frequency, every so many months we're going to do tests, or we're using input data from a predictive maintenance program as to when we do those tests. Now, as far as what you're going to run into for this testing is the different categories of testing. You're going to see throughout 70B, it's going to tell you, well, for this equipment, do a Category 1 test. Or do a Category 1A test on it. All that means is Category 1 or Category 2 means that the equipment's offline. Category 1A or 2A means that the equipment is online while you're doing the testing. And then Category 1, whether it's 1 or 1A, it's our standard test, our routine test we've been talking about and just demonstrated on that motor, right? Whereas a Category 2 test is a more enhanced test where, yeah, maybe we need to go to the power quality analyzer or the high pot or the polarization index test or whatever it is. So we've got to know those tests and know how to interpret, how to conduct them, and how to interpret their results as well. That's only about the first 4 chapters or so in NFPA 70B. Chapter 5 is on personnel safety. Oh, that's a real important one. We have to spend all day on that. No. It just tells you to go to 70E. And one little sentence, I think, is all it is. 70E tells us how to work on our equipment safely and those safe work practices. Now, as far as the rest of the topics then in 70B, different chapters, for instance, Chapter 11 is on power transformers. Chapter 12 is on substations. Chapter 17 is on switches. Chapter 19 is on how to maintain cable tray, how often we should do it, and what types of inspections and testing we should do on cable trays. Chapter 27 is a big one. That's on rotating equipment. And once again, it tells us what to do and how to do it. Protective relays is Chapter 35 and so on. So many different types of equipment. Virtually everything we have out there in our distribution systems is covered in NFPA 70B. Once again, we still go to manufacturer's instructions, other resources, other standards, and so forth that can help us. For instance, battery maintenance. So batteries are covered in Chapter 32, battery energy storage systems. But there are several, well, first of all, manufacturer's instructions, and there are also several different IEEE standards. Well, first one that comes to mind for lead-acid batteries, IEEE 480 for maintenance of lead-acid storage batteries and so forth. So anyway, there's lots more information out there in our reference documents beyond NFPA 70B then. Talk about an example back to that motor. As far as what must we do and how often. Here's what it tells me I must do to my electric motor. I have to do visual inspections. I have to do cleaning of it. I have to lubricate it if it's that type of bearing. I have to do mechanical servicing, and I have to do electrical testing on that motor. How often do I do it? Well, it depends. If I have predictive maintenance system I'm using, use that. If I don't, Chapter 27 on rotating equipment tells me, for instance, I do my electrical testing. If it's in condition 1, meaning it's like basically new equipment, I only do my electrical testing every 5 years. The worst case scenario would be condition 3. It's where that motor's getting older, it's been in service for quite a bit of time, or maybe we've watched some of the values start to decrease on our tests over time and so forth. So that drops it to condition 3. So now instead of every 5 years, I do my maintenance on it, my maintenance testing every year. And then what electrical tests do I do? it tells me in NFPA 70B what specific electrical test I should run on a piece of equipment. It's up to me, the maintenance technician, and my electrical maintenance program coordinator to determine the proper procedure to do on that equipment, follow that procedure, read, interpret those readings, and make decisions from there then. So, that is a lot of information on NFPA 70B, and we've really just scratched the surface, as you can well imagine. We didn't even talk about all of those other 30-some chapters or whatever on all the different pieces of equipment. Make sure you get your electrical maintenance program set up. The reason you're doing it is for safety and reliability. Safety of you, the technician, safety of the public and the facilities, and make sure that the facility itself remains safe and that your processes remain safe as well. That's why we follow NFPA 70B. Remember, this Tech Talk is brought to you by EC&M Magazine. They are part of the portfolio of Endeavor Business Publications. Make sure you go to EC&M Web and sign up for that premium content, and we'll see you at the next Tech Talk. And what? Make sure you work safe out there in the meantime.